Wait for a few people to join. Let's see what we have here. Hello, everyone. I see you all popping in. Yep. Good afternoon and welcome. Thank you for taking the time out and joining our Tech Talk one today during Game Changer Week. We are glad to have you here with us. I am Kelly Jones, Events Coordinator for Tech Center Research Park here in Newport News, Virginia. Before we get started, just a little Zoom etiquette. Place all questions in the Q&A feature and we'll answer that later on in our presentation. Feel free to network in our chat box. Let us know who you are and where you're from. Let's just have fun today. Before I kick it off to Jeff, welcome again, joining us during Game Changer Week. And without further ado, Jeff Johnson, our Director of Tech Center Research Park.
Hey, thank you, Kelly. Hopefully you guys can hear me okay. And it is my great pleasure to welcome you also to a special edition of the Tech Talk inside of the exciting Game Changer Week with the VTCRC. Before I begin and tell you more about this Tech Talk series and get to our great speaker today, I gotta give a shout out to the senior leadership team down at in Blacksburg that actually made this possible under the leadership of Brett Malone and Dawn also, Brett and Dawn. It's a fabulous, fabulous program that's going really well. And I wanted to make sure I thanked Melissa Vidmar, who really is executing this and driving this forward. So we appreciate the opportunity to be a part of it as part of the VTCRC family and the enterprise located here, as Kelly said, in Newport News, Virginia, for those of you who don't know, on the eastern side of the state. Of Virginia as well. So where we focused on really commercializing discovery and helping to grow businesses that matter. And today is really no exception. It is a fantastic opportunity to bring technology that really had its nascent origins at one of our federal research labs here with an amazing leader whom you'll hear from later. I'm going to take a moment and tell you a little bit about Tech Center. Tech Center Research Park not only focuses on commercializing discovery and growing businesses that matters, but we focus on helping move innovation from idea to impact. You're going to get a view of that today. And usually we set up these tech talks so that we give a voice to innovation. Leaders who are driving their businesses forward and has had some amazing success, as you will hear from Bill about the success of his company. But we also look for those who may need something, or whether it's access to technology, access to capital, or access to talent, or those kinds of things as well. So we wanted to really, really provide this as a vehicle to make this really something of value to our community. So with that, let me tell you a little bit about Bill. So the great news is I get a chance to introduce my friend, Bill Frederick. Bill's kind of a cool guy. You guys will get to know what I know. And not only is he a graduate of Purdue University, okay, with a degree in aeronautical engineering. Oh my goodness. He also worked at NASA Langley Research Center as a co-op student. So humble beginnings for such an amazing, amazing talent. He served in the Aeronautic Systems Analysis branch of NASA's Conceptual Design Group, where he was exposed to a wide variety of projects and research projects, which is really cool because this ranged from serving on the aerodynamics database team for Ares-1 crew launch vehicle to a system study to develop a fleet of small UAS that can dramatically soar inside of hurricanes to collect data for improved meteorology. We're all thankful for their work here with the hurricanes and weather, inclement weather that we've been experiencing here on the East Coast, most recently up in the Northeast as well. So we're really thankful for the work that Bill and the other team does in that area. But his two most notable projects at NASA were performing was performing the initial conceptual design for what is now known as the NASA X-57 Maxwell and the Grease Lightning Unmanned Aerial System, UAS, where he performed the conceptual design of the aircraft and led the project through its flight testing phase. I'm sure Bill will say more about this later as we talk about it and get into his presentation. He's also a former artillery officer in the United States Marine Corps. So Bill, I really want to say thank you again for your service to this country. Knowing you and knowing that you also deployed to Afghanistan in 2011 with the Rocket Artillery Battery HIMARS group. Bill currently leads Advanced Aircraft Company to design and manufacture long endurance VTOL UAS. And for those of you who don't know what all of that means, that's the reason we bring Bill here, so he can explain what that means. But without further ado, it's my pleasure to introduce the president and CEO and founder of Advanced Aircraft Company, Bill Frederick. Bill, the floor is yours, my friend.
Awesome. Thank you very much for that warm introduction, Jeff. And looking forward to speaking with you all today. And my intention is not to consume the whole hour talking, but to have some time at the end for a discussion and conversation and answer questions. All right, so I need to share my screen now. And share sound optimized for video. Here we go. And let's show video panel so I can see you all again. All right, can folks see my screen?
Yeah, you're good, Bill.
Okay, wonderful. So, hello everyone. I'm Bill Fredericks, founder and CEO of Advanced Aircraft Company. This is a picture of our product flying over Charles City County, Virginia. And we are in the business of selling our customers greater productivity. More on that in a minute. My background, I've got this thing. Let me get this out of the way. So my background, as Jeff mentioned, most recently, I worked for NASA as an aerospace engineer. I was in the aircraft conceptual design group at NASA. Before that, I served in the Marine Corps as an artillery officer, was in RC Southwest, Helmand Province in 2011. The Marines always get the crappiest areas, but in either case, I'm a graduate of Purdue University, and while at Purdue, I was also a co-op student at NASA. And picture in the top right is Grease Lightning. I'll talk about that a little bit more in a minute, but I did the conceptual design of that aircraft and led that project all the way through its flight testing phase. So let's dive into AAC. So first of all, what is the problem we solve at Advanced Aircraft Company? This is the so what for our customers. So the problem they have is battery-powered multi-rotor drones have reached the useful limits of the productivity they can achieve. Productivity is plateaued for the commercial drone industry right now. And the reason that's a problem is our customers generate revenue by the acre and pay their pilots by the hour. And right now they're averaging only 3.4 hours of productive utilization in an 8-hour workday. And if you think about that for a minute, that's a horrible productivity metric for a services industry. And that is the problem we solve at Advanced Aircraft Company. So why is this productivity metric so bad? The physics of batteries, specifically battery-specific energy, is not very high relative to liquid fuels. And that also leads to poor utilization. I mentioned on average right now, it's only 3.4 hours of productive utilization in an 8-hour workday. And those two things together lead to a very high cost per acre that the end user must pay in order to get that data collected. So what this means is the addressable market size is actually still very small because the price per acre that the end user has to pay for the data is still quite high. And as soon as there's a solution available to be much more productive, that the price per acre can come down for the end user, the market adoption rate of drones will ramp up very quickly. So that's the problem we're focused on solving at Advanced Aircraft Company. To continue this, let's say I change hats. I'm taking off the Bill Frederick's hat and I'm putting on UAV service provider hat CEO. When they decide what vehicles they're going to buy to go operate, this is the choice that's in the market today. First, you've got, can you all see my mouse? Is that, if I point with the mouse, can you all see it?
Yes, we see it.
Wonderful. So you've got the fixed wing drones. These are things that look like normal airplanes. And if they're going to carry a substantial payload, they have to come off a catapult, which is logistically burdensome. You've got multi-rotors, and this is 80% of the commercial drone industry right now is using battery-powered multi-rotors. Those are quick to use, but they can't fly very long. And there's also these hybrid quad configurations, also otherwise known as a lift plus cruise, or as I like to describe them, it's an airplane and a quadcopter having a baby. So the advantage of the hybrid quads is they get long flight times and they can operate out of confined areas because they're vertical takeoff and landing. There's two big shortcomings of this solution to solve this productivity. So the reason for the others are making these hybrid quads is to attempt to solve this productivity problem, to get the vertical takeoff and landing of multi-rotors and get the longer flight times of airplanes. The two big problems with these, first of all, is price point. All these systems are coming out dramatically more expensive. And second, and most people don't realize this, they have very limited hover ability. So if you're doing detailed inspection work, you can't use one of these vehicles because to get the long flight time, it has to be flying fast like an airplane. So say you're doing photogrammetry work or lidar work, and the fastest you can go is about 10 miles per hour to get the data you need. You can't use one of these vehicles. You have to use a battery-powered multi-rotor because these can't fly slowly. They can only operate in hover mode for a matter of minutes, but then they can fly for hours as an airplane. So those are the big pain points. Our hypothesis at Advanced Aircraft Company is the right way to solve this problem is to employ hybrid electric propulsion as opposed to hybrid quad configurations. So what this is it's a multi-rotor, just like a battery-powered multi-rotor. So it retains all of the positive attributes of multi-rotors because it is a multi-rotor. But what's unique about it is we're solving the key pain point of multi-rotors, and that's the limited flight time of batteries. So on the back end of the vehicle here is a internal combustion engine that's spinning a high frequency AC generator, which is being actively rectified back to 48 volts DC. And it's pushing electrical power onto the DC bus. And there's a much smaller battery pack on the DC bus also to provide backup in the event the engine were to fail. And so now we can fly for hours at a time. We can hover for hours at a time. We can fly slowly for hours at a time. So we're maintaining all the positive attributes of a multi-rotor. And the only thing that's additional from a user experience perspective when flying the drone is there's one extra switch, and the switch is run or kill. And run means the engine runs, kill means the engine shut down, and the propulsion system computer handles everything else, just like a modern car. To look at this from another perspective, let's look at this from the perspective of logistical footprint. So to level set expectations for the audience. So when people talk about drone operations, everybody thinks of the drone. But what people don't often talk about is the logistical footprint to keep that drone in the air. So if you've got a lot of area to survey, there's a big logistical footprint to keep that aircraft flying. So to fly one of these large DJI multi-rotors, you simultaneously need 6 batteries. And you need a minimum of 4 battery sets. And some of the operators we talked to actually carry 10 sets of batteries with them. And the reason for needing at least 4 sets is it takes 3 times longer to let the batteries rest and recharge than it takes to use the batteries in flight. Then you have to bring a whole bunch of gas with you. about 6 gallons of gasoline are required. And that 6 gallons of gasoline goes into a generator that you bought from Home Depot, for example. And that Home Depot generator is there to run at least 3 sets of battery chargers, often more. And that's why you need all the gasoline and the Home Depot generator, is to get those batteries recharged. You have the ground station to operate the aircraft. You have the pilot, the sensor operator, and a third person who does nothing but babysit the battery charger and the generator. So think of this logistical footprint and contrast that with the customer experience of our technology. So we also have the aircraft. We also have gasoline. We also have a similar ground station. You also have the pilot. You also have the sensor operator. In some use cases, you don't need the sensor operator. In other use cases, you do need the sensor operator. But the third person goes away. All the batteries to swap out goes away. The generator goes away. All those battery chargers goes away. And you just put the gasoline directly into the aircraft. And oh, by the way, fun fact, there's an environmental benefit of our gas-powered drone. We burn about 1/3 of the gasoline as the battery-powered drone we replace. So it's an interesting fact. And there's 2 reasons for that. First of all, the generator you buy from Home Depot is carbureted, and it's not very fuel efficient. The generator in our aircraft is computer controlled, fuel injected, so it gets a much better brake specific fuel consumption. That's one factor. The second factor, and most people don't realize this, the round trip efficiency of using batteries and recharging batteries is less than 60%. So those 2 factors combined, we actually only burn about 1/3 of the gasoline as a battery powered multi-rotor operation we replace. So all that technology stuff's cool. Former NASA geek, I love technology. Technology is exciting, but I at least can admit and recognize that our customers don't buy our product because it's cool technology. Our customers buy our product because it makes them more profitable. This slide tells that story. So on the y-axis is the cost of purchasing the aircraft plus the cost of operating the aircraft as a function of how much area you're serving. So this example is like a survey mapping use case. So when area surveyed equals 0 here on the left side, that's the acquisition price of each system. So the battery powered multi-rotor system, for example, the DJI enterprise drones like an M300, by the time you buy the drone, buy the sensors, buy the ground station, buy the radios, buy at least 4 sets of batteries, and your logistical footprint of the generator and battery chargers, they're spending about $25,000 to $35,000 to get all set up, ready to go. A drone like ours, equivalent setup with the cameras, we're about $70,000 to $80,000. So we're significantly more expensive. And then the hybrid quad configurations are approaching $200,000, and some of them are even $300,000 for those hybrid quad systems. The slope of the line is the productive utilization you get from your workforce. So the battery powered multi-rotor, I mentioned they're averaging only 3.4 hours of productive utilization, 8-hour workday. With our product, you can get nearly 6 hours of utilization, 8-hour workday. And those hybrid quad vehicles can get about 7 hours of productive utilization in an 8-hour workday. So you'll notice there's an area of unique competitive advantage for our product. So as soon as you're, if you have a use case where you need to, or you're an operator that you're mapping more than 80,000 acres per year, it's a cheaper solution to go with our product. And 80,000 acres sounds like a lot, and it is a lot. However, if your pilots are working 40 hours a week every single week, you could break even in less than 4 months. And that's a really compelling value proposition. And the reason for it is the busy drone service providers, where their employees are working 40 hours a week every single week, their business models are driven by the labor cost of their employees, and they're nearly insensitive to the purchase price of the drone. And so we're not everything to everyone, but for those operators that are doing a lot of work and keeping their pilots busy, we're a much lower cost solution relative to simply using a battery powered multi-rotor, because their workforce is so much more productive. This is my favorite photo of the team. This is a picture taken late last year, and it's a photo of a very motivated team, one, and it's also a photo of our first drone sale. So this is a picture of $93,000 of revenue sitting on that pallet. So where we are as a stage of a company, we reached our MVP, minimum viable product, late last year. We are now selling units, and so we've transitioned from that R&D company into that early revenue company. So there are operators out there who are using our product and paying us for it. So that's a key transition in the growth of the company that we're all very excited about. Moving forward, market opportunities. So this all sounds great and dandy, and but really, like, how big is this opportunity? So the first thing I want to do is talk about this from a top-down perspective. How big is the commercial drone industry? And I'm pulling 3 data points that none of these data points have anything to do with Advanced Aircraft Company. The first, Global Drone Market Reports estimated by 2024, the UAS industry will be generating over $40 billion of revenue per year. Now, granted, the vast majority of that number is at the services level. So about 20% of that number can be captured by the aircraft manufacturer segment of the market. Another interesting data point, it's estimated that this year, enterprise corporations, and only enterprise corporations, not talking consumers, not talking small service providers, enterprise corporations are purchasing over 800,000 drones this year. Another interesting data point, the growth of the enterprise drone market is currently growing at a compound annual growth rate of 51%. Now, that's just a huge growth rate for any industry, and that's specific to enterprise corporations employing drones. So that's not the drone industry as a whole. But the takeaway here is the first wave of the drone industry is the consumer industry, what I'll call the glorified selfie stick. The second wave of the drone industry is enterprise corporations using drones to collect actionable information to manage their enterprises more efficiently. So that's great. That's the top-down view. However, what's something more tangible? So advanced aircraft companies specifically, in today's regulatory framework, we estimate the total addressable market size for a product is about $500 million, about $500 million. And that's a bottoms-up analysis. And this is for 2 use cases. One is survey mapping, and 2 is infrastructure inspection. Now, that's a decent-sized market, but it's not a massive market. However, as the regulatory framework adapts, the demand for our product will spike. The reason for it is with battery-powered multi-rotors, once the regulatory framework exists to operate at longer distances beyond visual line of sight of the pilot on the ground, the battery-powered multi-rotor industry can't capitalize on that market because those vehicles don't have the performance to fly much beyond line of sight. So as soon as the regulatory framework advances for routine beyond visual line of sight, our total addressable market size grows to about $3 billion. And then as soon as the second regulatory step happens, where drones are integrated into the air traffic management system such that drones can then start operating in urban areas, this would be opening up markets like package delivery of drones. The total addressable market size grows to about $8 billion. So where we are today, we have a sizable market opportunity, but not massive. And there's a strategic shift that'll be coming in the industry once drones are able to operate at longer distances, that the demand for our product will grow significantly. Another interesting fun fact, just recently, a couple months ago, Advanced Aircraft Company, we won the First Responder UAS Endurance Challenge. And this was hosted by National Institute of Standards for Science and Technology, their division of the U.S. Department of Commerce. Pardon me. About 40 teams were accepted into stage 1, and 5 teams flew in the final round, and we took first place with a flight time of 112 minutes. And so just a few minutes short of 2 hours. And we were carrying 11.5 pounds of payload and flew nearly 2 hours. So that's the vehicle we flew in this challenge is actually a souped up version of what we sell now. So the product we're currently selling can lift 4 pounds of payload for about 2 hours. And we souped up the engine on it, made some other changes. And we're actually going to be taking this prototype that we used to win the first responder drone challenge and commercializing it. One of the things we're hearing from the market is folks want to carry larger, heavier, and more expensive sensors. So we sort of killed 2 birds with 1 stone during this challenge. One, it was a great opportunity to get some publicity, and we got some prize money out of it. And the other piece is to sort of move the needle to work on the big brother of our existing product line. So Hammer, which is our existing product line, is exciting. It's a profitable opportunity, but that's not why I left NASA. I left NASA to do Grease Lightning. So Hammer is sort of a means to an end, and the net income from our Grease Lightning product line will fund about half the R&D of commercializing Grease Lightning, and additional follow-on investment will fund about the other half of Grease Lightning commercialization. So what is Grease Lightning, and why is that important? And what was the value proposition of the NASA research? At a top level, the value proposition is we proved you can have your cake and eat it too. So Grease Lightning gets the aerodynamic efficiency of a conventional airplane, something that needs a runway or something that needs a catapult, and its vertical takeoff and landing. So those hybrid quad configurations, those lift plus cruise vehicles, the aerodynamic efficiency that they achieve is a compromise between an airplane and a multi-rotor. Grease Lightning gets the aerodynamic efficiency of a normal airplane and its vertical takeoff and landing, having your cake and eating it too. So what are some of the markets for Grease Lightning? The most obvious one is as a DoD tactical UAS. So right now that market is dominated by In Situ, now a Boeing company. And they've got huge catapults and these catch mechanisms they call a skyhook. Their drones can fly about 24-hour flights with a lightweight payload. Normally they're carrying more payloads, so they fly 16 to 18-hour missions. But the logistical footprint is so significant, it takes about 2 days from the time they get all the equipment deployed into position, set everything up before they're ready to launch the first aircraft. 2 days, that's a significant setup time. With something like a Grease Lightning, that can be reduced down to about 30 minutes. And our Hammer, as a data point, is only about 4 minutes with 2 trained personnel. From the time you arrive on site to the time that aircraft's in the air, about 4 minutes with our Hammer product line. Grease Lightning will be about 30 minutes because they'll need tracking antennas set up, but there's no other catapult and catch mechanism that needs to be assembled and then calibrated and op-checked before launching the first vehicle. So DoD market, clear opportunity. Another market opportunity as the regulatory framework advances, linear infrastructure inspection. So let's use one particular example. Say natural gas transmission pipelines. So in that market vertical, if you talk to the gas companies, they say they typically lose 3% in transmission. Some EPA sources say the leakage rates on some of these transmission pipelines actually exceed 10%. Let's assume the leakage rate is 4% for this conversation. 4% leakage rate times the quantity of natural gas produced in the United States per year times the price per cubic foot of natural gas is $4.2 billion. And it's like, whoa, you ask yourself, why are we wasting $4.2 billion every single year in this country alone? And additionally, there's all the environmental implications to that too. And the answer is there's no practical way to inspect these pipelines with a reasonable frequency. And right now, because you can't have a guy walk down millions of miles of transmission lines. The way this is mostly done now is from satellite data. Satellite data doesn't get very good resolution, and there's also the temporal issues. So by the time the leak is detected from satellite data, it's a really big leak and a really bad leak that's been leaking for a long time. What if instead you had a magic carpet and you could put your methane sniffer on the magic carpet? You'd want your magic carpet to be able to go quickly such that you get a low cost per mile. The problem with the magic carpet going quickly is you'd have to set your sensor threshold so low that you'd also be getting false positives. So you would need to be able to have your magic carpet to stop and stare, take a closer look, confirm or deny whether there is or is not a leak on that pipeline, and then go whipping down that pipeline again at 50 miles per hour so you can cover hundreds of miles per flight. Well, that magic carpet is grease lightning, and no other UAS being manufactured today can be that magic carpet. So grease lightning can inspect over 400 miles of pipe, I should say, could inspect over 400 miles of pipeline per flight. And it can hover multiple times during that flight to confirm or deny versus those hybrid quad vehicles. They only have 3 minutes of hover, and that's it. Another key opportunity for a grease lightning type product, and say it was a battery powered only vehicle instead of a series hybrid electric vehicle, would be package delivery. And there's a lot of companies getting in on the package delivery space. And honestly, with the battery powered multi-rotor vehicles that are being used today, that is not a scalable business opportunity. And the reason for it is with a battery powered multi-rotor, your maximum delivery radius is only about 5 miles. So if you were to want to scale up those operations to cover an entire metropolitan area, you'd have to be building fully stocked distribution centers every 5 to 7 miles to actually have the coverage to be able to get to every house in that area. And that's just not a scalable business opportunity. We all know that Amazon started beating up the big box stores because their percent inventory cost is very low. So a few distribution centers with 2-day shipping can serve the entire nation. And if you start doing, you're shooting yourself in the foot from a business model perspective if you have to have fully stocked inventory every 5 to 7 miles. Now, conversely, what if you had a drone that could fly twice as fast as a battery powered multi-rotor and could deliver a package at 4 times the delivery radius? Area covered goes with radius squared. So a 4 times increase in delivery radius is a 16 times increase in area and approximately a 16 times increase in the number of customers that can be served per distribution center. Now you could build 1 at most 2 distribution centers to serve an entire metropolitan area. And now that's suddenly a scalable business opportunity. So that's another market vertical that grease lightning could serve. In a second, I'll switch to some clips of the NASA public affairs video. And we have a licensing agreement worked out with NASA. So Advanced Aircraft Company will pay royalties to NASA. And NASA, because they're generous, will pass a small percent of those royalties back to me personally as the lead inventor on the NASA patents. Okay, so let's switch to the video. Yes, wonderful. NASA program. This video is NASA.
2009.
And this
Really?
was during
Yeah.
this is the NASA research phase that I led when I was still an employee at NASA. So the first thing you notice is oh boy. Oh, I've just bollocks it up. There we go. It took off just like any other multi-rotor. I'll mention that we had a pilot flying And it was not autopilot. It'll be augmentation system on it. Oh, Jeff saying, you can't hear. Can you hear me?
Actuator stop.
Oh, can't hear me anymore.
Now we can. Now we can.
Okay, you can hear me now. Okay.
Airspeed's good. Continue climbing.
Not while the video was going.
Oh, interesting. So,
There's 100
all right,
meters.
then I'll just stay quiet for a minute while the video is going. So, sound transition.
All right, hover mode in 3, 2, 1, hover mode. Well done. Nice.
Okay, awesome. How can folks hear me again now? Can I get a thumbs up or something on my audio? Okay, wonderful. Yeah, so some things to point out. You noticed how on the upper surface of the wing, we put pieces of orange yarn. We tufted the upper surface of the wing for flow visualization. And you'll notice in transition, the wing was completely stalled. And that's sort of a monumental fact. We're the first tilt wing aircraft to perform transitions above the critical angle of attack on the wing. So what that means was if the flight control system, if the stability augmentation system were to have failed during those flight conditions, the vehicle would have instantly tumbled out of control and crashed. And when you looked at if you're standing on the ground or if you're riding along on the drone, and we didn't tough the upper surface of the wing, you just would not have ever known that it was such a chaotic flight condition. And so that was the other unique piece. There's very few aircraft that can fly steady state at post-stall angles of attack. And one of the advantages of distributed electric propulsion, and this is actually where the whole DEP concept came from, was with Grease Lightning, is at very high frequency, we're doing differential throttle commands on those electric motors to provide artificial stability to the vehicle. So that was the unique research value that we did at NASA. So wrapping things up here, in summary, the drone market is big, and it's desperately in need of an aircraft technology upgrade. So let me use an analogy of the cellular industry. So the original cell phones, like flip phones and stuff, you could talk on them, and you could do like the multi-click texting. It was kind of clunky. And that's sort of where the most of the commercial drone industry is today. And then the smartphone came out. And what's interesting, the smartphones are about 5 times more expensive than an old flip phone. And you can actually still buy old flip phones, and the old flip phones are significantly lower price than a smartphone. And you have to ask yourself, why do people spend 4 to 5 times more money for a smartphone than they do for a flip phone? And like the market has clearly shown that the smartphone, even though it's significantly more expensive, is the dominant cellular device. And the answer is you're much more productive with a smartphone. You can do a lot more with it. And that's a great analogy of our drone. We sort of see ourselves as leading that next wave of the drone industry. It's a lot more than just a selfie stick. You can do a lot more with it. The other big thing to talk about is the market we're going after is a blue ocean opportunity. So the Chinese are not well positioned to capitalize on this enterprise drone space that's growing very quickly. It's still in its infancy right now, but it's growing very quickly. In addition to the US federal government deciding it's an IT security threat to use a lot of these Chinese produced drones and drones connected to the internet, a number of enterprise corporations have made the same determination. For example, one of the companies we're speaking with, yeah, I think I can say we don't have any NDAs. So we've been trying to pitch the Berkshire Hathaway portfolio companies, and they've decided completely independently of the US federal government that drones made in China, as well as internet connected drones, are a security threat to their enterprise. So they're only going to be buying drones that are not made in China and not connected to the internet. So the incumbents of the consumer space are the incumbent manufacturers of the consumer space are not well positioned to move up into the enterprise space. And additionally, the incumbent manned aircraft manufacturers of today are not well positioned to move down into the drone space. So there's no large incumbent in this market yet. In terms of progress from a financial perspective, we recently closed our seed investment round, where we raised $850K. Total investment raised to date in the company is about $2.1 million. We are planning a $5 million Series A in spring of 2022. So right now we are focused on growing revenue, more sales, such that we can do that Series A venture capital round with a respectable valuation. Additionally, this is no longer an idea. This is no longer a prototype. This is a product that we're selling, and customers are paying us for a product to solve their problem for them. And last thing, something that's really unique to AAC is we're not a one-trick pony. Hammer is not our only product line. We've got, we will be reinvesting the net income of our initial products into follow-on products that are of greater performance, like Hammer Neo, Hammer XL, the big brother to carry bigger sensors, and then Grease Lightning. So we see ourselves always sort of staying at the leading edge of the vehicle tech industry. And we're not everything to everyone, and we play nice with others. So we're not a software company. We are starting to build out a digital layer to the product, but we're not that camera company. We're not that app company, but we're making a marketplace for those things to happen. Like, for example, Google Maps or Uber would never be a company until the smartphone first came out with that data system in place. And with that, I'll pause, and we can start with questions and comments, and let's open up a dialogue and a conversation.
Wow. So listen, Bill, I mean, listening to your presentation, I'm sure we have a number of other folks here. I'm sure they're as floored with your presentation as I am. This was unbelievably impressive. Now, I am personally very proud of you. When Bill and I met back in when I was doing the EIR at Langley.
Or EOP, the Entrepreneur in Residence. Yep. Yeah, yes. So that was back in 2016, I believe. This was before I left NASA. Yep.
So this was just an idea, and to see how far you've come and how much you've learned in what's been developed is really impressive. So I'm going to leave it open to Kelly and to others of you who are here, and I won't hog the floor. You guys ask Bill questions, and I'm sure he'll have great responses for you. Kelly, I'll leave it to you now.
Perfect. Okay, first question. Doug Wanarina, great presentation and congrats to you and the team on your first sale. How far will the 5 million Series A take AA? Will it take you to break even?
Wonderful question.
Yeah, actually, we are not planning for a Series B raise. I know this is going to sound crazy and unusual, but we're a hardware company that gets software-like margins. And we do not believe we need a Series B raise. So the Series A round of 5 million is all the additional capital we need to grow to exit.
That's the only question as of right now.
Okay.
Anyone else? Feel free.
Don't be bashful.
I have a question. What is your current need?
Our current need is to grow sales. So if folks on this call can make introductions or provide leads, growing revenue is our current need to get us positioned for the Series A round. So that's our current need, is growing sales and introductions to customers. And I saw Crystal said hello, and she's with Dominion. I'd love to hear about that. We're actually in the Dominion Energy Accelerator managed by DEIC. But I'd love to learn more about what you do at Dominion, Crystal. Maybe that could be a follow-up where we could talk about it now.
Absolutely.
We'll make sure that your information in this presentation is passed along, Bill. I see a couple questions over in the Q&A,
Oh,
right?
right.
We missed
Two
those.
two just popped in.
Okay.
Mr. Ancliffe, hello. What industries are your first customers in? What industries are your first customers in?
So one of the things that was interesting, and I tell a bit of a story as I answer this question. So we're focused on survey mapping and infrastructure inspection, but no plan survives first contact with the customer. So our initial go-to-market was to make a kick-ass drone with modular empty payload bays that the customer could integrate the sensors that they want and like. What we've found through a lot of our customer discovery conversations and sales pitches too is a lot of folks have said, hey, you're awesome drone, but your drone is required but not sufficient to make a sale. And the answer often goes along the lines of, pardon me, we don't have electrical engineers on house. You have to integrate all those cameras and sensors for us. You deliver the system, give us the training, and the following day we're out using it. So we've actually not made any sales in survey and mapping and infrastructure inspection yet. So we've sold 4 aircraft so far, and those 4 sales were folks that wanted to just buy the empty pickup truck. So the first one is actually getting a military quality camera gimbal integrated in it, and they'll eventually be selling these to SOCOM, Special Operations Command. The second one is being used for drone pilot training. The third one is having methane sensors integrated to perform methane leak detection around oil wells in West Texas. And the fourth one we just sold actually to Civil Air Patrol. They're putting in a persistent systems radio in the payload bay, and they're actually paying us engineering service hours to help them with that integration. But the drone is basically a comm node. So they've been tasked by the Air Force to have a capability if a natural disaster or whatever the situation is knocks out the existing infrastructure. A drone can go up in the air with this mesh networking radio that can provide an Ethernet high bandwidth communications. So those are the 4 sales we've had so far, and the market verticals they're in. And yeah, those have been companies that don't need the turnkey solution, but we're interested in the empty pickup truck to integrate things into.
One more. Have you identified potential investors? Have you had any early discussions?
Yes and no. I've been keeping a list of folks that I've been speaking with, but like for example, one I check in periodically with is NRV, New Richmond Ventures. There's one in one of the Carolinas that's military veteran focused. And there's a couple others we've had initial conversations, and they said the come back one thing, basically wanted to see more revenue before we come back. But open to introductions. And Doug, hello. Be great to reconnect with you. But the short answer is no, we don't have a hard target list yet, and we're open to warm introductions.
All right, that is-
Fantastic. One of the things we spoke about, Bill, is your team growing? Right now, you're generating some revenue, and I think at some point we needed to augment the team. So access to
We
talent.
just
Talk to us about
hired
that.
a mechanical engineer, and we're also just trying to decide which is the next hire, whether it's another mechanical engineer or an electrical engineer. We haven't decided that yet, but yeah, we just did a recent hire. So the team is 8 people right now, and 2 are part-time. Yeah, so we're still a small team, but we'll be growing. Yep, and we are hiring.
Fantastic.
There are no more questions, Jeff.
Fantastic. Well, listen, I know that this was again a great presentation, Bill. I appreciate you taking the time. And for those of you who took the time to give up your lunch to come and listen to Bill talk about a great technology and innovation, where he's clearly taken it from idea to impact, right along the continuum that we're very much focused on here at Tech Center, and focused on as part of the VTCRC enterprise and a family of technologies that you guys are getting a chance to see and hear from all week during Game Changer Week. So I thank you, Bill, for taking the time, my friend. We'll follow up with you with any other questions and contacts that we have on this end. And I thank our attendees, of course, for taking the time to come in to spend the time here. And I got to thank my host, Kelly Jones, who really put these together. And throughout all of the pieces that we have, we really, really appreciate your work, Kelly. And thank you to all of you for joining us. And so we give you back 7 minutes, unless there's any other questions. All right. Thanks, everybody.
Well,
Have a
thank
great,
you for
great
having
rest of
me.
your
Tech
day.
Center on social media.
Oh, go ahead, Kelly.
Please follow us on all platforms: Facebook, Twitter, and LinkedIn. Tech Center Research Park or Tech Center VA. Bye.
And thank
Thanks,
you, Kelly.
everybody.
Jeff.
You are very welcome. Very welcome.
Take care, Bill.
Bye.